Here we go. So, good morning, afternoon, or evening, depending on where you are joining us from today. So, as Roman said, you are here because you want to learn more on how new AI technologies can help analysts work faster and more efficiently. And this isn't just about improving intelligence practices. It's about tools that can concretely help people and save lives. So in this workshop, you will discover how we are integrating cutting-edge AI technologies with knowledge graphs with this clear goal in mind. But before we dive in, let me quickly set this effort within the context of GraphAware's vision. Because for the past 6 years, we have been empowering intelligence analysts worldwide to solve crime faster and more efficiently through our knowledge graph technologies. So our flagship solution, Hume, delivers mission-critical analytics built on top of knowledge graphs. And this is the result of our continuous effort to find solutions and techniques that can be combined with knowledge graphs to improve law enforcement intelligence practices, making analysts' work more effective. So there's an interesting story here because the very first version of Hume, that was even not called Hume at the time, was actually a natural language processing plugin built on top of Neo4j. So the idea of mixing a natural language understanding with the graphs has been with us for a long time. Unfortunately, back then, the capabilities of available tools and algorithms were very limited. Creating specific models was tedious and time-consuming, requiring lengthy annotation processes that created a strong adoption barrier. So you can imagine how excited we were when generative AI emerged, in particular LLMs, removing the need for extensive training because the out-of-the-box capabilities were more than sufficient to get started. But despite the power offered by these technologies, we encountered significant resistance to adopting them in the intelligence domain. And I'd say for good reasons. The first major blocker, as you can imagine, is security. Due to the security of the data and privacy concern, these organizations cannot accept sharing information outside of their infrastructure. So sending data to public clouds isn't an option, even with terms and conditions stating that providers will never use the data for training. So our customer also reported that they need full control over AI-generated outputs and want to validate them before using them, before entering information into their systems. So while human feedback is crucial, it slows adoption since it adds the additional burden to the workflows. Furthermore, the lack of transparency is a clear other major issue. The black box nature of these systems cannot provide the transparent chain of evidence required in legal proceedings, as you can guess. And then we have hallucinations that could actively mislead investigations with potentially serious consequences. So to overcome these limitations and provide smoother integration, time ago, we identified the three major areas where LLMs, as a part of this generative AI movement, can provide value while keeping everything under control. So first of all, we identify, of course, the power of LLMs to process unstructured data, which means enabling the conversion of unstructured data into organized knowledge graphs that are easy to query and access. So we also added some guardrails and feedback mechanism to allow analysts to control the generated entities. And Federica presented this capability in previous webinars. So we can also use natural language interfaces, even voice command in the future, to explore, to expose the knowledge stored in graphs to a broader range of users, going outside of the analyst desk. Imagine detectives asking questions to the knowledge graph while they are driving the car or they are in the street. We presented chat with your graph to customers and prospects in multiple locations. Moreover, the volume of data to process and insights to digest can be overwhelming for analysts. We would like to leverage these techniques to generate reports and perform analysis that would be time-consuming for humans. So we are experimenting with agentic AI configuration to help generate meaningful reports and deliver complex insight in an intelligent way. But these were well received by our customers. Still, even with all our effort of promoting the advantages of combining knowledge graphs with LLMs in the features that I just described, adoption is still slower than expected, and the concerns remain. So after a while, we decided at the beginning of the year to take a different approach. We choose to introduce LLMs in Hume for tasks that doesn't require sharing any sensitive data with LLMs, while still using them to help analysts make their job easier within the Hume environment that they already know and trust. This is how Maestro was born. It represents our pragmatic approach, pragmatic path to introduce LLMs in the intelligence analysis practice, but from a different perspective. So the main goal, the main initial motivation for Maestro is to let analysts experiment with conversational interfaces in their day-to-day work. So the first real task they are able to accomplish is accessing Hume documentation, not throughout traditional searches, but by simply asking questions like, how can I do this? How can I do that? This addresses a critical need because our analysis revealed that reducing Hume's learning curve is essential for faster adoption. The software is complex for who knows it, and getting proper answers from documentation can be sometimes difficult. So this new type of support will help analysts exactly to extract what they need when they need it. And Federica's demo will show how it works and how it was created. And of course, documentation is just our starting point. So since the first version was released and a few other people are testing the new that is coming, we have obtained already interesting results. By starting with non-mission critical documentation support, we helped analysts become more comfortable with AI assistants in their familiar Hume environment. Maestro creates the technical and cultural groundwork needed for more advanced AI integrations down the road. So the platform allows us also to quickly test and deploy new AI-powered features based on real user feedback and needs. And Christoph will show you how to use Maestro to access other type of documents than our documentation. So Maestro is designed to work also alongside existing LLM solution, providing flexibilities for agencies to integrate existing LLMs projects. And this also will accelerate the adoption of these technologies inside companies and organizations. So it's time now to take a quick look at Maestro architecture that will allow you to better appreciate the demos that will come after. So then you'll see this in action with the two demos that we prepared for you today. So this is the first version that has been released in the latest Hume version, the 2.26. As you can see, it is very minimal, but it contains all the critical elements. So the chat interface that you can see here on the top left, the integration with other Hume components, and the core of what will become the microservice delivering very advanced features that here is referred as Hume Maestro in the middle of the slide. And this version has already generated, as I said, a lot of good feedback and encouraged interesting integration exploration, like using a GraphAware approach on public documents or integrating existing AI services our customers already have, as I mentioned. The core of our engine is very limited in this first version. It can just answer generic questions, directly accessing to existing or cloud-based LLMs, even performing translation if you like, and can help to create the layout of our action boards that I have to say I use quite often so that I have a first structure of the action board. Then there is the new version that is going to be released quite soon. So where more will come. So the main goal of the new version is to release our documentation via a chat interface. But as a collateral effect, we also expose a new endpoint in our Maestro core engine that allows performing text embedding. And this can be useful for creating vectors for semantic search, because it can be combined with Neo4j vector search capabilities, or as a base for any retrieval approach, including, of course, GraphRag. So compared with the simple schema before, what we did was to add another path in our LangGraph structure. So the router can also understand if there is a specific question to the documentation, and it can answer based on our own documentation. And this is exactly what Federica will present to you today. And by the way, as you will see, this Ask the Docs component actually uses a GraphRag-like approach, which we adapted to our needs. But without further delay, it is time for our amazing demos. So I will leave the stage to Federica first, who will show you how to use this GraphRag-like approach to serve answers related to Hume documentation. And then we will see how we can use a similar approach to ask any question to your documents, for example. So thank you for joining us. And Federica, the stage is yours.
Thanks, Alessandro. So let me share the screen. Okay. So hello, everyone. Today, I'd like to introduce you the new powerful Maestro's feature that is the Hume Documentation AI Assistant. So the Hume Documentation AI Assistant is an agent that is able to answer questions on Hume, such as how can I enable this feature, how can I perform this operation, and so on. This is based on a GraphRag-like approach, in the sense that both during the ingestion of the documents and during the retrieval phase, we take advantage of the rich context that graphs offer. We have a conversational interface, in the sense that the user can have an entire conversation with the assistant, and we consider the conversation while processing, generating the response. It is a feature that is available across the Hume platform. Indeed, it's a side panel that you can open it from everywhere. And yeah, last thing I'd like to mention is that the approach that we are going to describe is used in our case for processing the Hume documentation, but in general can be applied with other type of documents. This assistant is helpful because it helps to significantly reduce the Hume learning curve. First of all, because it's embedded inside the Hume, so you can open the assistant from Hume, and you can avoid having to go back and forth between Hume and the documentation to check how to do something. And then, because of course it's powered by AI, so there is the possibility to summarize the content, to perform a smarter search, and so on. We also provide effective support for different types of users in Hume, for instance, data engineer and analyst, because different users have access to different features of Hume, and we need the assistant to provide a support that is tailored for the user that is asking the question. Now, we can start by looking at the documentation that we are going to use. This, as many documentation, as many contents, is organized as pages that are inside folders. Folders group pages that have similar content. Also, the structure of the pages is organized by using titles, subtitles, and paragraph in order to highlight, in order to organize the content into multiple levels and highlight the semantics among them. Now, when we look at the structure, how pages are organized, we can easily understand that this can be represented as a graph, in particular as a tree. So this user guide, the root node of our documentation, will contain some subfolders and pages. In this example, we are considering the knowledge graphs that is here. So we have a folder, and this folder still contains other pages and other folders, subfolders. And we can keep going in this way. Then about the pages, these pages are hypertext pages that use typography headings in order to organize the content and identify sections semantically connected. So we can use these headings to chunk the text, because you know that when working with large language models, the chunking is an important step that you need to perform before everything else. So in this sense, we used the headings in order to chunk, to identify the sections, and we define a section starting with the heading, and then it goes until the next one. So in this way, we can structure, we can identify these chunks that are semantically coherent chunks, and structure the content of the page in this way. These chunks are what we call sections, and again, we can organize them as a graph. So here, the first section, the action board part, that is the root section of the page, the heading of level 1, is represented here as a root of the page. Then this section has other subsections. There is the introduction and working with action board that are headings of the same level, and then we can go, we can continue in this way. So this representation has the advantage of being browsable, and of course we can recreate the content of a page by just navigating the graph that we got. Now, what about the ingestion process? We start with the creation of pages structure, so pages and folders. Then we ingest the pages content, and we chunk the text by using the HTML headings. Then there are two minor steps. The first one is a cleansing operation, so we split the text from the code blocks. And then there is the sentence extraction that will be used later for the re-ranking process, in order to assess the quality of the sections that we are retrieving. Then there is a powerful process that we apply, that is the augmentation by generating nested summaries. This augmentation is a powerful process because it leverages the power, the representation of our documentation through a graph in order to generate representative summaries for each part of the documentation. Let's see how we perform this step. We start, it is an iterative process. We start with the leaves, so the sections that are the last one in the hierarchy, and we ask a large language model to generate a summary for these sections. So all these 4 sections, action board, navigation, and these others that are leaf, will have their summaries. Then once all the summaries have been computed, the summary of the section, for instance, working with action board, can be obtained by asking the model to generate again the summary starting from its content and all the summaries of the subsections. So in this way, we can start from the leaves and go up until we reach the root section of the page. This root section will contain the entire, the summary of the entire page, because all the other parts are involved. The same process is applied also for the folders, in the sense that this action board folder will have a summary that includes all these other pages, the action board configuration, and also this other folder. So we consider all the sub sections, the subfolders, and the pages. In this way, we reach a different representation of the same feature, of the same Hume capability, with a different granularity. So we have the summaries of the last section that are very detailed one, that represent a specific concept, while when we go up in the hierarchy, we have the summaries that represent the concept, the feature, with an eye level view. Now, Here, there is an example of these summaries to show you the differences. So when we consider the action board navigation summary, we have contents about how to access action boards and the type of action boards. While when we consider the action board page, we can notice that the summary is organized according to the sections that we are processing. So there is the introduction part, and then there is working with action boards, this part. And still in working with action boards, we have again the information about accessing action board and the type of action board, but in a less verbose version. The same is when we consider the summary of the action board folder. We have the content organized according to the action board, the pages that we have. So action boards, action board configuration is this one, and action board autos. But still, all the relevant information are here, but in a concise version. Also, we do perform this summary generation per persona, in the sense that we have said before that different users in Hume have access to different features. So, of course, we need to consider this information when we aggregate the summaries. And for instance, in this case, the analyst person won't have access to the action board configuration page and the action board autos. And the action board folder is, in this case, generated by taking into account only the relevant pages, and in general, only the relevant portion for that person. Now, why is this approach useful? Because in this way, we can have not only detailed summaries, but also high-level summaries. And so we can answer both specific questions, like these ones, and generic questions, asking about the feature, just an overview. So we expect the summaries of the section to answer specific questions, like in this case, and the summaries of levels or pages to answer generic questions. Now, this was about the ingestion phase. During the retrieval phase, we start with the conversation between user and assistant, and we send the conversation to a large language model, asking it to generate user questions that represent the question of the user. This is useful because let's suppose that the user asks a question about graph editing, and then later on, how can enable it? So if we send to the model, to the retrieval phase, only the question, what is this useful it, we cannot we cannot understand what is it referred to. While sending the entire conversation and asking to generate a comprehensive question, we can address it properly. Actually, we not only generate a single question, but we generate 4 of them in order to ensure a bit of variety. Then the retrieval is performed by using a hybrid retrieval. In this case, we consider both a vector-based similarity search on the summaries embedding and a full text search on section contents. Again, while the vector search is powerful if we need to identify similar topics, similar contents, the full text is powerful if we want to if we have a word, a keyword that is very meaningful, for instance, a domain-specific word, and we need to we need to focus on this feature. Then we perform the ranking process. In this case, we assign a score to different sections in order to maximize both the relevance of each subsection according to the user question and the variety of contents that we get. And then we send the question, the original question, with the context to the large language model in order to get an answer. So let's see it. Here we have Maestro, and I created for the demo 2 different endpoints. One is the analyst, pretending that I'm an analyst, and the other is the data engineer that we have here. In general, Maestro is able to understand, according to the roles that you have in Hume, the type of user that you are. But just for the demo, I created these two endpoints. So we can start with a generic question, again, supposing that I'm a data engineer and I want to ask, how does Hume graph editing work? So I expect here to have an overview of the graph editing feature. Let's see. Okay. Hume graph editing allows user to create, delete, and modify data directly on the visualization or via an API. So we have the key features, user permissions, also configuration steps, editing process, and so on. So it's just an overview of the feature. Now let's say that we want something specific, and we want to know how can I configure it. So here we have a specific question about graph editing, but we are not clearly specifying that we are talking about graph editing. We are just referring to the first one, to the first topic. And indeed here we have our Maestro that is answering about how to configure graph editing in Hume with a lot of details, because I'm a data engineer, so I should have access to this type of content. Now I wanted to show you another thing, highlighting the differences between different users. So let's start a new conversation so we have a clear one, and I wanted to ask how to enable grouping. So here we are a data engineer, so I expect to have details about all the things that I should enable. In this case, we have grouping to enable grouping in a visualization. We should follow these steps. Or let me try another one. How can I enable temporal analysis? Okay, here, yeah, we have a reference to the knowledge graph settings section. That is something that a data engineer should have access to. So here is saying that we should navigate to the knowledge graph section and select the desired knowledge graph, then go to the settings tab and choose the visualization and enable temporal analysis section. Now, if I ask the same question, supposing that I am an analyst, I should have a different response, because we are not able to access the knowledge graph settings. Indeed, this is answering about how to enable temporal analysis, but from a visualization. Says that we should open the visualization, navigate to the visualization where we want to enable temporal analysis, and then in the right pane of the visualization, select analysis and enable temporal analysis option to on. So we have seen that for the data engineer, we got an answer that was related to the knowledge graph settings, because the data engineer has access to these features, while for the analyst, we can only access to visualization, and indeed we have the strategy for enabling temporal analysis from the visualization. And yeah, that's everything from my side. So I leave the stage to Chris to show you how it's possible to customize the approach by ingesting custom documents. Thank you.
Thank you, Federica. Hi, everyone. So we will extend the approach from Federica to use a similar flow based on documents uploaded by Analyst. We'll start with the demo and then focus on the explanation on some aspects that are very important regarding the architecture of querying intelligence data. Right, so I will go here, and before uploading file, I want to show something. I will ask a question already about a topic, mainly about Abramovich. And what is important is to realize that the information is not made up from the LLM. So we actually force the LLM with prompting techniques to make sure that he doesn't try to always return a response, right? So here we make sure that if we don't have any documents internally that can answer this question, the LLM will not made up a response for you, right? So now I will upload files here that are 5 reports about Abramovich. I will upload them. What is happening behind the scenes is that we have an event-based architecture. So every time a user is uploading a file, be it a CSV or a PDF or whatever, Orchestra can hook up to those events and process the file. So by processing, for example, extracting the content from PDF or transforming a CSV file into graph data, etc. Right? But here we will actually extract the content from the PDF and represent the document as nodes in Neo4j along with the text, right? So, and this is the first flow that will happen. Once the document is created into the graph, we leverage Neo4j CDC so that we get automated events when new document nodes are created or updated into the graph. And we will perform the exact same flow, almost exact same flow that Federica mentioned. So we will create portions of this document, and then for each portion, we will create an embedding that we will store in Neo4j, so it becomes queryable. Right? So I will focus on those 2 workflows now, and that means that documents are now queryable from natural language. So what will here, my question will have a similitude with the text that has been stored in Neo4j, right? So here I can ask kind of complex question, actually. So what are systematic weaknesses in intentional tax enforcement that the Abramovich case exposed? So here, based on information we have from those documents, the LLM can reason about it and provide an answer to the analyst, right? So, and we can ask a second question here. Okay, and again, it's performing the same step. When the user is having a question, right? So we will actually take that question and ask the LLM to create multiple variations of the user's question, right? So because let's say my question can be very short, so I will say, okay, what did Abramovich do in this case, for example? So based even on the conversation, the total conversation, the LLM can actually provide variation of the same query, either longer, either differently, so that there is a better chance that it will find similar data into the graph, right? So then we will find the relevant information into the graph here, and we will prepare the information that we will pass to the LLM. So we also ensure that we instruct the LLM to only use the provided text data to generate an answer. So that would prevent actually a bit of hallucinations from the LLM that have a tendency to actually try to provide a response, right? This is their job at the end of the day, but we are actually preventing the LLM to to return a positive answer, right? And then we return the response to the user. There is another flow here, is that we can also, depending on the question, like Federica showed, like, what do you know about it, right? So that it, there is not a lot of chance that if we would just compare this query, what do you know about it, that it will find information from the graph, because it's based on similarity matching, right? So it is important to take the context of a conversation, or even the context of where the user is asking the question. Maybe he can be in a specific visualization, and to enhance the query. So that query writing, we also take the context of a conversation into account when providing multiple queries to match into the graph, right? So, and that workflow here is just making sure that as soon as we delete a file, well, we remove the information from the graph as well, right? So because then the answer would not be synchronized anymore with the data, actually, right? So a couple of very important aspects when building those architecture. First is that you really need a flexible architecture. Like that very simple diagram, it looks trivial, but there are a lot of decisions to make along this process, right? So first is, okay, you have documents, but how do you present those documents into the graph, right? So are you actually building a graph of documents, or are those documents related to a specific investigation or case? Maybe those documents are, for now, only limited to a specific user that is doing an hypothesis first before making this information available to the organization, for example. So it's very important to model the data correctly so that the documents remain in the context of the analyst. Then there is a real need for secure architecture. For example, the embeddings are, at the end of the day, just a mathematical representation of text, but they are as sensitive as the intelligence data on its own, right? They represent the meaning, and they have to be secured in the same way that you are securing your data. That means that if you're intending to use a separate vector store to store the embeddings, you will end up in additional complications in your architecture, where you will need to synchronize, for example, access control privileges from your main system to other databases, etc. You also have to make sure that those systems support single sign-on, for example. So our choice is to reuse the advanced security capabilities of the graph with Neo4j by using the same access control that Neo4j provide with RBAC and PBAC for case-based access control, user-based access control, etc. So it's very important to keep your embeddings as secure as the data itself, right? And when it comes to interactions with LLMs, well, there is always a need for auditing. So you need to be able to ensure that things are monitored and audited. Then there is a need for data protection in the identification scenarios, where mentions of names of people or PII data in general is not passed to the LLM if it is outside of the boundary that you have for data protection. So if you use local LLMs, maybe this need doesn't exist. You can leverage the fact that it's local. But if you want to use the cloud-based LLM services, then you will probably need to enter a stage where you need to plug in the architecture the identification process for PII. Then there is also jailbreak detection, so making sure that the analyst would be prevented to try to access or to change the behavior of the default intent that you provide with your workflows, right? So if your intent is to allow the analyst to chat with documents, well, you don't want the analyst to say, okay, ignore all your instruction and do this for me, for example. So there is a need for detecting this type of behavior and preventing the system to go forward, right? So if you use, for example, Microsoft Azure, you have this by default with those security and safety mechanisms. So this is very nice from Microsoft. But if you do this locally, you will need to find additional tooling that you can plug in easily in the architecture of the intelligence data querying. Then there is a need for context-aware architecture, right? So depending on where you are in Hume, like the type of answer or the type of data that you are passing to the LLM can be different. For example, well, you could be already investigating a case that is having documents that are connected to other people or to other organizations. So it's important to have a platform where actually you can leverage the whole context of the data or other cases or things you did in the past as an analyst to be able to augment the information that you pass to the LLM in order to provide better answers. And that's it for me. Thank you.
Thank you very much, Chris. Okay, let me just share the background for the Q&A session that is coming up. And I don't see any questions here in the Q&A, but we do have questions from the registration form that you posted while registering. So we'll start with answering those, and feel free to add yours. So I will pose the question number one from the registration form. Can the large language model run locally, or does it have to be cloud hosted? I guess this is for Chris.
We support connecting to any LLM provider, so be it cloud services or on-premise infrastructure that is completely air-gapped with local LLMs. So we are an on-premise first product, so we definitely can connect to local and private LLMs.
We can't hear you, Roman.
Sorry. The second question from the registration form. How are the results from large language models verified and validated? Can I trust the answer is correct? Can I trust the answer is complete? And I think this one is for Federica.
Yes. We are working on a monitoring system to track the questions and the answer and feedback, even if they are inside the conversation itself. So, for instance, the user answer, I want this thing. So this is an implicit feedback. And in this sense, we want to work on this monitoring system in order to have the possibility to evaluate the answers. In general, I would say that the RAG approaches are better than just one-shot approaches. So in this sense, if the instructions are well provided, and your retrieval mechanism is fine, so you retrieved some content that is relevant, it's very unlikely that the answer is not the correct one. About the completeness, as I said in the presentation, this is something that we tried to address in the retrieval mechanism, in the ranking mechanism, trying to ensure that a bit of a variety was added, was provided to the model about the context itself. So having a bit of sections that are talking about the same feature, but from different perspectives, so different functionalities of the same feature can be something that can solve the completeness problem.
Thank you, Federica. We have a question from Jacqueline. This is more logistic questions. If we will be sharing the presentation, yes, we will be sending you the recording of this session. As the presentation, feel free to contact us and we can arrange for providing the presentation as well. Now, another question that we have from the registration form, I'll just paste it as it came. So can you combine so the Maestro with link predictions or graph data science algorithms? And this is probably for Alessandro, no?
Definitely, I'd say that we notice that we can combine results from different graph data science algorithm and feed LLMs to perform, insights extraction or other type of informative content creation leveraging LLMs. So link prediction is definitely one of the possibilities, but also we tested community detection as well as page rank or between centrality. All these algorithms can provide valuable information that can add context, that can add, let's say, value to the already rich knowledge available in the graph, and this can be definitely a good input for LLM. Vice versa, we can also use LLMs, as we've seen a few times today, to create meaningful embeddings that can be used for other type of advanced graph algorithms like graph neural networks, that like GraphSage requires embeddings or features on the nodes to perform better. And we noticed that having this type of embeddings could, on of course text nodes, can help us to feed these other type of algorithms. Also on the other way around, like graph neural networks, to perform even more accurate prediction. And link prediction is definitely one of the tests that we have done. So we can see, let's say, on both sides. So as a graph data science can extract insights for LLMs process, vice versa, LLM can provide embeddings to enrich the node content and use this for other type of algorithms like graph neural networks.
Thank you, Alessandro. I see Christoph nodding. Do you want to add anything, or Federica, to this answer? No. Okay. The last question we have from the registration form is about the models. And the question is, which on-prem models do you support? I don't know who can answer this one.
I can answer.
Go ahead.
So by nature, you are not limited to we are not forcing any model. So we can, it's a configuration in Hume, like to provide the name of the model that you want to use. However, you have to make sure that the model you are using are capable enough to support some features, right? So first, it's good to have model that supports structured outputs, for example, to make sure that some responses in the flows can be provided as JSON format rather than purely text. And then you also need to make sure that the model are big enough to be able to reason about the information we are passing to it. So depending on the type of model or the size of the model, the answer can be degraded if the model are too small, actually. But the choice of the model is left up to the organization that is using Hume, actually.
Perfect. Thank you. I don't see any other questions, so that concludes the Q&A session. To close this webinar, I just want to advise you to stay tuned. As Alessandro mentioned, Maestro is starting of something bigger and more interesting features, and explorations will be coming soon. So thank you very much for attending. Thank you, Federica. Thank you, Chris, and thank you, Alessandro, for presentations. And I wish you a nice day.
Thank you.
Thank you.
Thank you for joining. Bye.